All right, welcome to your second set of notes for the week. These are notes number 4, and they should be done before you do your ALEKS number 4 assignment. These notes are going to help you. So make sure that you guys finish the notes before you start your ALEKS.com assignment. Make sure you have your paper all set up with name, date, period. Essential question, how can I use the list to do a proof? So I'll show you in class, so you should have already seen the list. It is a PDF on PowerSchool, and it will help you a lot with proofs. It will help you to figure out what these reasons are. So the list is really important. So anyways, this was our DMR problem. It should be finished. I'm going to go ahead and just slide this up. That way you guys can get this next part. So we'll do one at a time. So this, remember you guys pause it as you need to, and I'm going to zoom it in just a bit so it's easier to see. Remember, after you're done taking notes, go back and do your 3 questions on the side. So there should be a question right here that relates to the information in this chunk. It's the middle chunk of information. I'll do my best to remind you guys as we go, but it's really important that you go back and reread your notes so that you can learn and remember. It's not like if you write it one time, you'll remember it, at least not for most people. All right, so here are some definitions from the list. I numbered the first one 2 because on the list it's actually the second one. So the 2 will tell you where to look, and these are the definitions from the list. There's also postulates and theorems on the list, so it's important to know the difference. So definition of an angle bisector. That could be a ray, segment, or line that cuts an angle in half, making 2 congruent angles. So get used to seeing things written out kind of short. So 2 congruent angles means this, 2 congruent angles. And remember from the previous notes, we learned that congruent means that they're the same shape, like the same shape and size, but we're not exactly saying that they're the same measure. So it makes 2 congruent angles. So basically, I just say it cuts it in half. If you have, I'm just going to use pencil for this example. If you have an angle like this, and then it's got an angle bisector, it cuts it in half. So maybe it was a 60-degree angle. Now it's got 30 degrees and 30 degrees. So an angle bisector cuts it in half. I know you might write your question here, but that way you just have like a small little picture example of what angle bisectors are. Okay, so if you know that something's an angle bisector, these two should be equal, and then they'll add up to the big angle measure. All right, here's something very, very similar. Again, you guys pause as you need to so that you can write it. This is a definition of segment bisector. It's number 3 on the list. Okay, so I'm just going to go. You guys pause if you need to. So it's really important that you understand what these are. Once you know what they are, you can kind of just look at the list and you'll know what, like you'll hopefully remember what they are. So it is kind of like the angle bisector. It is a ray, segment, or line that cuts a segment in half. So that's what I always think. It cuts it in half. Like this one up here, if it was a 60-degree angle and it has a bisector, then it's 30 and 30. It cuts it in half, divide by 2, basically. So you get making 2 congruent segments. And I wrote it out so that you know what that symbol means. 2 congruent segments. So a segment bisector, you get 2 congruent segments. Angle bisector, 2 congruent angles. So what I have here is a diagram. Please write it down. We have line L. It's line L. It has a little cursive L. It says line L bisects AB. So I'm going to use highlighter to just really show you guys what's going on here. AB is the whole line segment from this point A to that point B. And we're not even talking about the measure of it. We're just saying that's what it looks like. So there's no numbers for the actual measurement. But if I know that AB is this segment and line L is a segment bisector, that means, and I didn't show point M because I wanted you guys to see, it bisects AB at point M. So M is that point. Write it in. And M also could stand for midpoint if you're thinking about it that way. That's why I chose M. It's the midpoint of AB. Midpoint, it's in the middle. So anyways, this symbol means if and only if. If and only if means that this goes both ways. You could read it forwards, or you could start with this end information and then say if and only if, and then that part. This is something we'll talk about more. It's called the biconditional. So anyways, segment AM is congruent to segment MB. So let's look at the diagram. Segment AM is right here, A to M, and then that would have to be congruent to MB, that one. So from here to here. So that makes sense if you think about it. Okay, so if line L is a segment bisector, it cuts it in half. It cuts AB in half right here at M. And then it makes sense that this blue right here would be equal to the purple. And we use congruent because we're not talking about measurements right now. So we would say that AM is congruent to MB. So line L bisects AB at point M if and only if AM is congruent to MB. And like I said, you could read it backwards. Backwards would be this. AM is congruent to MB if and only if line L bisects AB at point M. So the only way that those two could be congruent is if line L is the segment bisector. All right, moving on. You guys pause if you need a break ever. I'm just going to keep going. So this is on the list again. It is the number 4, so it's like on the list on the left. Definition of congruence. We talked about what congruent means, but the definition of congruence, it's something that we'll use as a reason quite often when we're doing proofs. So write it down, pause if you need to. I'm just going to go. So it says if the shape of a segment, angle, we could actually be talking about shapes like triangles or quadrilaterals, but for now we'll think about segments and angles. If the shape of that is congruent to another, then they have equal measure. And it goes backwards too. If like two segments, let's just say if two segments have equal measure, then the shape of a segment is congruent to another. So it kind of can go back and forth backwards. So I've got right here written out shape. If shapes are congruent, wait, I'm saying it wrong. Shapes are congruent if and only if, like the measure of one angle equals the measure of the other angle. Or you could be saying the measure of a segment is equal to the measure of another segment. Then their shapes are congruent. So I'm going to just, I think it makes sense when I made this little example right there. So if I have segment AB and segment DE, they're different segments, but you can see the way I wrote them, they look like they're probably the same length. So they're congruent. I did make them congruent because I stated it right there. If something is stated like that, it is true. So segment AB is congruent to segment DE if and only if this is talking about the measurement. Measurement of AB is equal to the measurement of DE. So again, this may not be drawn to scale, but if I'm talking about measurement, I can get a ruler and I can measure, and it doesn't matter what you use, centimeters or inches or whatever, but I could just measure it and see if they are the same measurement. They should be. And again, drawings are not drawn to scale. I just drew it for the example. But if the measurements are equal, then the segments are congruent. So definition of congruence can go both ways. If you have two things congruent and you want to say that they're equal, that's definition of congruence. If you have something equal and then you want to say it's congruent, definition of congruence. It'll make sense when we use it. So this is in your notes, especially so that you can refer back to it. All right, so now we're going to get to some examples. So that's mostly it for like the writing, like the definitions. I didn't want to do too much. So now we're going to do some examples. So this is straight from your ALEKS homework. Remember, when you're doing notes, keep it with the Cornell note style because you should come back and have a question here, your number 1 question for the page. Oops. There, see, so you should have 3 questions on this page. So when you're working on your ALEKS number 4 homework, you can use this to help you. And you can use the previous notes as well. They should help you because this one reviews, like ALEKS number 4 reviews a lot. So anyways, write this down. It says in the figure below, the measure of angle 2 equals 40 degrees. Find measure of angle 1. So you guys are probably pretty good problem solvers. I want you to just kind of think, what do you know, given this diagram especially, and how can you find the missing angle? So pause and think about it if you want to, but I'm just going to keep going. What you should notice is this little thing means that it's a right angle. So I would know right away measure of angle 1 plus measure of angle 2 equals 90 degrees. That's something that I just know right away. So that's a really important thing. That means 90, a right angle. And then looking at the information given, like if that's all I knew, I couldn't do anything. But they did tell us, I'll use another highlighter, that measure of angle 2 equals 40. So I can go to my diagram where it says the 2, I can put 40 degrees. So I'm sure you're thinking now, you already know what to do. I could plug in the numbers, it would be a little more complicated, but really I just have to do 90 minus 40 to get the missing angle. I'm looking for a measure of angle 1, and so that is 50 degrees. So you will have a problem like this on ALEKS. So measure of angle 1 equals 50. I do want you guys to think about checking your answers. So in order to check my answer, I can think, okay, measure of angle 1, I do know, I'll just write equals 50. If it's a 50 for angle 1 and a 40 for angle 2, if I add them up, they equal 90, and it is a right angle, so it should equal 90. So that's a quick way to check. All right, this one looks a little more complicated. This is also on ALEKS. It's number 15. The reason I want to go through this is because for some of you, all these naming angles and measurement of angles, it might be very new. You may not have seen this much. So I wanted to make sure we do go through this. Again, pause as you need to, guys. So here's a diagram. Take the time to draw it. I'm just going to start going. So measure of angle ABD is 112. So that's the measurement from A to B to D. So I'm going to trace it just to show you. So ABD, that whole thing is 112. I'm not going to write it in because it's kind of like all over the place. If I wrote it right here, it stands for that angle. If I wrote it here, it stands for that angle. So that whole thing is 112. I highlighted so I can at least kind of see it there. Okay, I'm also given that measure of angle EBD is 34. So let's see, EBD. So that's this one. It's 34. So I'm just kind of showing, I have to look at the given information, I write it on the diagram, and then I'm able to figure it out. Okay, so this is where we're going to use the definitions that we just learned. Segment BE bisects an angle. It is an angle bisector. Okay, so I'm going to look back real quick at the notes. Angle bisector, it's a segment that cuts an angle in half. Okay, so it cuts it in half, making two congruent angles. So those two congruent angles have the same measure. So if BE bisects angle CBD, let me trace that one, CBD. That tells you something. So use some logic to think, what does that tell you? So you should be thinking, okay, so this is bisected by this segment. BE bisects this angle. This cuts the angle in half. If this is 34, this is also 34. So I only know that because of that keyword, bisects. So that tells me, oh, that one's also 34. Okay. What I need to find is the measure of ABC. So always be thinking, what am I even trying to find? Because there's a lot of things I could be doing. I want to make sure I'm doing what I'm supposed to. What is the question asking? So ABC, I'm trying to find that part. Okay, so given what we know, I bet you guys, some of you could figure this out. But one of the things I would do is I would think, let me see. I would think to add up these, and if I add this one too, that equals the total. So if I could add 1, 2, and 3, these three angles, it should equal the total angle, which is 112. So I do know two of them. It's 34 and 34. So I would do 34 plus 34, and that's 68 degrees. So these two together is 68. Let me slide that up a little. Okay, so that gets me partway there. And then I know ABD is 112. So if I know that this whole thing is 112, and I already know that this part is 68, I think I just have to subtract this 68 to get this part. So let me try that. 112 minus 68. You want to borrow. And then it's 10 minus 6, so 44. Okay, so I'm thinking that that's probably 44, if I did everything right. So how can I check? I think that I found measure of angle ABC. I think that it's 44, but I want to check it. So I can check by adding 44, 34, 34. That should equal the total 112. So check it. 44 plus 34 plus 34 equals 112. And it does. If you check it, it does equal 112. Check. So that way I know that I got it right. Okay, so just use the given information, write it in. Bisect was important because I know that those two are equal. Okay, and then I just add them up, subtract it from the total angle, which is 112. So use this to help you on ALEKS. Here's our last problem for the day. And ALEKS doesn't really have that many proofs. So we'll mostly do the proofs together in class. Okay, so write this down and then we're going to start going over the reasons and stuff. So complete the following proof. Given that segment XZ is bisected by line J, we want to prove that M equals 7. So in the diagram, always use the diagram for information, you can see that there's the variable M and that this is XZ. I like to come up with a plan before I start writing stuff. So I'm kind of thinking, okay, if XZ is bisected by line J, here's line J. I'll use another color. So if it's bisected by line J, there's that information. If I look back at the list, I want to find what's the definition. What does that mean? We're looking at segments. It's a segment that's bisected. So it cuts a segment in half, two congruent segments. And I didn't mark it here, so I'm going to go back and mark it. You do want to mark congruent segments with just one line if there's only one. So if you had like two sets of congruent segments, you can do like double lines. But anyways, we'll get there when we get there. So one line to mark congruent segments. So what I would do, I'm kind of just going to plan this out. So if XZ is bisected, then I know that these two segments are congruent. And then I know congruent means that their measures are equal. So I could set up an equation making this 8M equal to this 5M plus 21. And then I should be able to solve for M. So I would recommend to do that on scratch paper. Let's see how that works out. Because remember, I kind of told you guys, when you actually write the proof, it's kind of like formal, like an essay when you turn in the final draft. You want it to be nice and neat and clean. So I'm thinking that since it's a bisector, these are two congruent segments, they have equal measure. Let me solve this and see if I do get 7. And then I'll know I'm on the right track. I just have to write it out. So I would subtract 5M to get the M's on the same side. 3M equals 21. Divide by 3. M equals 7. Oh, it worked. Okay, so basically, I kind of didn't explain this that much. A proof is proving. I mean, it sounds like that. So I'm going to prove that M equals 7. It's almost like if every step of the way someone's asking you, why did you do that? Why did you do that? Why did you do that? Prove it to me. It's so like I could solve it real quick, you guys can see, but the proof is justifying each step, saying why can you do each step. Okay, so here we go. You always start number one statement, number one reason. I look at what was given and I write that down. So statement number one, XZ is bisected by line J. Reason number one, given. Okay, so I do want to put one more given. Sometimes we write givens from pictures. So given this picture, I do have information. I know the actual numbers, like what those two equal. So I'm going to write that in here. So this is going to be another given. Sometimes you have different things that are given. So given, I'm going to write xy equals 8m. And then I'm going to write yz, it equals 5m plus 21. And again, that is a given from picture. But I want to just say given from pic. It's a little shorter. Okay, so the next thing is, when I was going through my thought process, I can't just jump to like working it out. I have to say why I do everything. The reasons are like someone's asking, why can you do that? So what I have to say first is, remember how I was saying, oh, these two segments are congruent because it was bisected. So I'm going to put that first. So the way we write that these two segments are congruent, I have to look at the letters, like how are they named? I would write XY, segment XY is congruent to segment YZ. So that's the two in the yellow. Those two are congruent. And the reason is because of that definition. Remember when I said bisected and I said look at definition from the list. Definition, I'll just put list. Oops. Look at definition on the list. So that is definition. I'll actually show you guys. What you write is exactly this, definition of segment bisector, but we can say def for short. So that's what it says, that those two segments are congruent. See how it even looks the same? It looks the same like how I wrote it. All right, so def of segment bisector. Okay, once I knew, oh, those two are congruent, then I'm going to use the definition of congruence, because congruence doesn't really deal with numbers. Remember how I worked it out already? That has to do with equality, not congruence. Congruence is this symbol, and those are equality. So if I want to, it's kind of like converting. If I want to go from congruent to equal, I'm not changing anything except for the congruent symbol to the equal symbol. When I do that, I have to use definition of congruence. Okay, so I'm going from congruent to equal. So now I'm saying the measurements are equal since the two segments are congruent. Now I can do something really cool. Given what I had right up above, I can put numbers in. So I'm going to plug in what xy is actually equal to, which is 8m. 8m equals, and then I'm going to put what yz is actually equal to, the actual numbers. It's 5m plus 21. I want you guys to think, why? Why can I do that? Okay, so you know this property. It is a property from the list, but it's not one that we wrote down. It is called the substitution property. Substitution prop. So if you think about it, we did just substitute 8m for what it's equal to, 5m plus 21 for what it's equal to. So that's substitution property. All right, now it's basically solving. And I just have to justify each step with the reason. So I'm just going to go through that. What we would do, actually, let me see if I can show this side by side. Again, I don't want the work. When you're doing your proof, you don't want to show the work. So if I'm going from this step where I wrote the equation to the next step, it's kind of like there's this one, there's that one, and then there's that one. Okay, so I'm going to only write on my next the 3m whoops, I lost it, equals 21. And so remember what I was saying, it's like, what is the reason? Why can you do that? Why can you go from step 5 to step 6? What was done? What was changed? And so as you're asking yourself those questions, you could think, okay, I subtracted 5m to both sides. That's the property of equality for subtraction. Subtraction, POE. Okay, and then I'm going to look back. You can see it's really important to do your work ahead of time so you can plan it out and make it look nice. Now it's just the final answer, and that's also the thing we're trying to prove. We got m equals 7. Okay, so 7th step, m equals 7. Why? How did I go from step 6 to step 7? I know I subtracted here. What did I do from 3m equals 21 to get m equals 7? Division, and you can see it in your work. What was done to both sides? Dividing by 3. So that's the division, POE, property of equality. Okay, that's it for the proof. You can check it by plugging in 7. I probably should have done that, but it did tell us prove that our main goal is to prove what it's telling us to prove. If you do substitute in 7, it does work out. They are equal. All right, so just make sure you get your questions and summary and review. Watch this again if you need to. Your summary should be 3 sentences. And get used to clicking on PowerSchool to see the list. These things are on the list, so that way you don't have to memorize them. Well, not the given, but these definitions and properties are on the list. So make sure you're very comfortable with clicking on PowerSchool, find the list, that way you can do this. All right, good luck, and make sure you do your questions in your summary.